Okay, I'm reporting you to how I progress in Vector2. I first show how to compute a dot product of two vectors. And here I have a formula for dot product which I mark at this time like with this specific not later mark, and here we have a formula for that when the v vector is over here and we dot product with w vector, we find a number which is the scalar by this formula, and we can do it with this 2D vector over here. So I put them to this formula like this, plus no, not like that. Let's see, the first ones are multiplied to each other, and then we adding them with the second one. So there we have our dot products. And that is like 6 minus, because there's a minus over there, and minus 3, it gives our dot product scalar number 3. And then there is a cross product of two vectors. It is only can use cross product with 3 dimension when the R is R3 and the 3 is like this. So we have to make this one for the 3rd dimension like having them like this. But in this case I show you first how this formula works. Excuse me. There is 2 vectors which are cross product, so we make them a 3rd vector. There gives us a vector which begins their crossing point and then them, and the length of the vector is the direction is it is easy to explain you with this this kind of animation where the cross point is two vectors. How did I say? 90-degree with both of those vectors, and then there are length of them is the angle, is related with angle of that angle between them. So I had a layer where that I show you those two vectors, what I meant that their length is the area of these two vectors. So how this works in practically we find by this formula to find those two vectors. So if we put here k, let's make it a little k, and then we put L over there, we find that there is a 3 minus 1, and of course there's a 0, and then there is a 2, another one is 3, and then there is a 0. So we put them to this formula. We can now this is the first one, though take out of each others, so we cross product only these ones. So the minus 1 0 is a 0, and then 0 to 3 is a 0. Here all this become a 0. And then there's another way, and then there is a y-axis when there became a 0. At first there's a 0 over here, and then it's 2 over there, and then there's a, which is 3, and then there is another 0. So we get this another 0. So there is only it is the length of okay, and let's make the last one. There's minus 1, and there's a 2, and then there is 3. Oh, excuse me, I made a mistake, because first we get a 2, third one, and then there is a -1, like this, and let's make those over there. So there we have a 9, and plus 2, it's 11, like this. So we have another vector which begins, which comes out of the screen 11 units. So there is our vector, cross product vector of this L and K, and the length is, I assume that it is 11, but you can calculate that. And then there is an angle between two vector. The angle over there. Let's draw it. Angle over there. Oh, what happened? Oh, that wasn't. Let's take a pencil over there, and it is called. Oh, this doesn't work perfectly. Let's see. Okay, that was my mistake. I have. Let's. What? This is not a good one for for painting. But anyway, this is the angle, and we can find that angle by this formula for calculating these ones. By two vector product is length of those vectors multiply with cosine at a let's call it at miukumauku, and then cosine miukumauku is equal to vector v cross point vector w divided by length of those vectors, multiplied vectors, and then the miukumauku is r cosine of that formula over there. And how we can do it, because this is a number, now we know that excuse me, this one over here is a number, as we know it over there. We can put 3 over there, and then we have to find the lengths of those formula, and we know how we can find the length by Pythagoras theorem. And just a second, I would have them to you. Okay, now we have a length of those vectors, and the length of the k was square root 10, and the length of the L was square root 13.